This is our third lesson on computer systems called Fetch, Decode, Execute cycle. Now, please remember that I am following the GCSE Computer Science OCR specification, which is J277. So before we move on to each stage separately, let's understand what Fetch, Decode, Execute cycle is. So, what happens as soon as you switch on your computer, the fetch executor cycle starts and it consists of several stages. So, fetch execute cycle is cycle that the CPU runs through billions of times per second to make a computer work. As we are all aware, the CPU is the brain of the computer and is made up of components and registers. So, a computer, we need to understand this. A computer takes an input, processes the input, and then delivers an output to the user. So, if you would have watched my first lesson on basic computer systems, I gave you an example of making smoothie. So, what was our input? Our input was our fruit. What was our processor? Our processor was a blender. And what was the output? It was the glass. Similarly, there's an example here. Input, if you're playing a game, you're clicking a button. What is the process? The CPU inside the console follows a set of instructions to carry out the task. And output is the player moves on the screen. So let's look at each stage individually. So what happens during the fetch stage? The program counter holds the address of the next instruction to be fetched from memory. And when we look at this in detail, you'll understand what is the job of a program counter. Just imagine a program counter being if you were doing some swimming lengths across a pool, you had a little counter in your hand and you did your first length, then you went back and did your second length. So, exactly the same concept. The program counter holds the address of the next instruction to be fetched from memory. The address of the next instruction or data to be fetched is copied into MAR. The address of the instruction data is then sent along the address bus and awaits a signal from the control bus. The signal sent along the control bus is sent from the control unit to the memory. The data or instruction received from main memory is fetched to the memory data register via the data bus. A copy of the instruction or data is stored in the CIR and the program counter is incremented by 1. So it is pointing to the next instruction to be executed. What happens during decode stage? The CPU needs to work out what is required from the instructions. So what the instruction is and what is it going to do with it. During the execute stage is the CPU will carry out the instruction that was fetched. Some examples are like calculations. Others might be going to main memory to fetch data from a different location. So the four things which are really important that we should remember are: an instruction or data is fetched from memory, the instruction is decoded, the instruction is executed, the cycle repeats billions of times per second. So let's understand how all these three work together. So, as I already mentioned to you previously, the program counter holds the address of the next instruction to be fetched from memory. So, this is our program counter. What is it doing is that it is holding our address of the next instruction. What happens? So, say for example, I said add 12 plus 8. That is my instruction. So, as soon as I've typed that in, the program counter will copy that instruction into MAR. That instruction will go via the address bus, okay? And these are memory locations. So, these are memory locations, and this is your data or your value, okay? It can be data or value which is stored here. So what am I saying? Copy, so load 3. So what is load 3? I'm saying load 3, what is in 3 memory location? 12. So 12 is loaded into MDR. How is it loaded? It takes the data bus. This is our data bus. It takes, why is it called data bus? Because it's carrying data, which is 12. It goes to the MDR, so it's copied there. Then what happens? The CIR, which is current instruction register, it's holding that information. So 12 is being held by CIR. Then what the main boss, which is control unit, decides what to do with that instruction. So as it is 12, it will load that 12 into ALU. So that 12 is loaded into ALU. What happens next? Now I've asked it to add 8. So what will happen? This program counter will increase to 1. Next, same process would follow. This instruction is copied into MAR. It will go via the address bus and it will say add a 4. Now, as you can see, what is in 4 now? You can see the 4 is now 8. Our data is 8 in 4. So we will now, what will happen? It will exactly do the same. Go via the data bus, take that information, put it in here, copy it here. So 8 is copied into MDR. Now CIR will hold that 8 till the control unit decides where does that 8 go. Obviously, it's a number. ALU will have that 8 now. So what will happen is now ALU, instead of having 12, it is going to have 8. So what did I ask it to do? I asked it to do add this. So the addition of 8 plus 12 will be put here, will be stored in the accumulator. So the job of the accumulator is to store your result. So let's look at the next slide where this is happening in action. So what is happening? You fetch your instructions, is fetching load 3. What is in 3? 1 is in 3. So it's loading 1. So that's loaded. Then it says load a fetch, it says a fetch instruction which is in 4. So it fetches that which is 2. So you can clearly see it fetches 2 from our address, and then it's asked you to add this, execute it. So it fetches, decodes, and then executes your information. So let's look at the steps. The steps are, the program counter is loaded with 0. So as we looked here, the program counter is loaded with 0. Then what happens? The value from the program counter is copied to MAR. So in our example, what did we do? We copied that instruction into MAR. Then what did we do? The data from the MAR is sent across the address bus with the instruction to read the data across the control bus. Okay, so we read that data which was sent across. Then what happens? Now you might say, but I didn't mention control bus. Yes, there is a control bus which comes here, which you really don't need to know, but it's fine. Control bus just carries your instruction. Okay, the control bus. The data from that location in memory 0 is sent down the data bus to MDR. So we did exactly the same. That instruction was copied via data bus, and then the control unit decided what to do with it. Decode stage. The data is sent from the MDR to CIR. This is sent to the CU to be decoded. So we did this. From here, CIR is holding 8, then the control unit will decide what to do. That is called decoding that information. Then what happens? Then the control unit, who is in charge, who's the main boss, decides what to do with that instruction. So, for example, in our case, in our example, the ALU had to come into action because it was a mathematical calculation. So, same thing. Which register will come into play will depend on the instruction. So, if it was hello, it would have been a different instruction. So let's look at an exam question. Identify four events that take place during the fetch execute cycle. So these are the four events. An instruction is fetched from memory. The instruction is then decoded. The decoded instruction is then executed so that the CPU performs continuously. The process is repeated. The program counter is incremented. The instruction is transferred to the MDR. The address of the instruction to be fetched is placed in an MAR.